In this video, we'll be doing an example of the dependent t-test, which we'll be calculating by hand. And so in this example, we have some data here. So we have data about how many grams of sugar, of added sugar, these 4 people. We have 4 participants here, 1, 2, 3, 4. And so how many grams of added sugar they have in their diet on this particular day that we've asked them about. And then they receive some sort of information, perhaps a pamphlet or a video or something about the importance of reducing added sugar in their diet. And so we follow up with them about a week later and find out on that particular day how much added sugar they've had and they've consumed as part of their diet on that day. And so we have this information, and we know that for the dependent t-test, we have 2 scores that are paired in some way. Very often this is a before and an after score. So this could be 2 scores from each of, in this case, 4 participants. Well, we could have any number of participants for this, but we're going to have 2 scores from each. There are situations where we have the dependent or the paired t-test. In other situations where we have matched pairs or some other kind of research design. But for this scenario, we have before and after scores. And so the first thing that we're always going to do when we're using our hypothesis testing procedure is going to be to determine what our research and our null hypotheses are. And we're specifically going to phrase this in terms of populations. And so here I've started writing our research hypothesis here, R, which I've abbreviated as RH. And we have participants who view this information, and specifically, our research hypothesis is going to be that they will eat less added sugar after viewing this information. And so specifically, we're going to pay attention to this word less, because we know that we're going to come back to that in step 3 when we have to determine our cutoff score, and we want to know whether we have a directional or a non-directional hypothesis. And so I'm just going to make this little underline here to remind me of that later. For my null hypothesis, we know that the null hypothesis is going to say that the research hypothesis is not true, that there's no effect of this information that I've given these participants. So I'm going to start off just the same way here. Participants view this information. But instead of them eating less, we're going to say that they will not eat less added sugar. And so that's step 1 of my hypothesis testing procedure. For step 2, we know that we have to get the information about our comparison distribution. And so in order to do this, the first thing that I'm going to do when I have a dependent t-test is, if I haven't already done so, I'm going to, or if it's not given to me, I'm going to calculate my difference scores. And specifically, I'm going to calculate after minus before. And so if I do this, I'm going to have 32 minus 66, 55 minus 57, so this column minus this column, 1 minus 64, and 41 minus 62. So I could bring this up to calculate these. And again, I always recommend doing these on a calculator just to avoid any silly mistakes that we might make if we're doing this just by hand, or especially if we're trying to do this in our heads. And so now I have my difference scores. And so from here, I can go ahead and calculate my mean of my difference scores. And we know that our formula for the mean, I always like to keep all of these formulas accessible and write these down as I'm doing these calculations. So we have the sum of our x's minus n we know that our x's here are just all of our raw scores here. So I'm going to add all of these up. I want to make sure to know how your calculator wants you to be using negative signs. Sometimes you'll need to use parentheses. On my calculator down here, I have this negative sign that I'll have to be pressing after I put each number in. That's going to be important to know. And so here I have minus 70 divided by n, which is the number of scores I have, which is 4 here. The number of participants in this case, or number of different scores, since I've already gotten that information. And so negative 70 divided by 4, and so I get negative 17.5. And so that's going to be the mean. The next thing that I'm going to do here is I'm going to estimate our population variance. And so specifically when we're working with the dependent t-test, when we're working with the t-test in general, we know that we don't have our population variance, that this is unknown. And so we have to estimate this. And so in order to do this, we're going to use the formula that we've discussed in an earlier video. So we have s squared here, that's our symbol for our estimated population variance. And that's going to be very similar to the variance formula that we've already talked about very early in a much earlier video when we talked about sample variance. So this is the sum of x minus m squared all over. And in the case of our estimated variance, we're going to use n minus 1. And that's our formula for those degrees of freedom. And so if I set this up, we're going to use our different scores. So at this point, we basically use our different scores as if this is all we have now. We're going to kind of forget about all of what our earlier before and after scores, and we're only going to be using our different scores from the point that we calculate them on. And so here, we're going to have, I'm going to put down all of my x's here and subtract. And then n is going to be the mean of my different scores, which we calculated in that last step. And so I'm just going to calculate these off on the side here. And so if I have negative 34 minus negative 17.5, that's going to give me negative 16.5. Negative 2 minus negative 17.5 is going to give me 15.5. Negative 13 minus negative 17.5 is going to give me 4.5. And negative 21 minus 17.5 is going to give me negative 3.5. And so here we've gotten the x minus m part. And so next up we have to square these. And so again, an important reminder here to make sure that you know how your calculator wants you to deal with negatives. Particularly, you may have to put them in parentheses in order to make sure that this will square properly. An important thing to remember is that when we're squaring, we're multiplying the number by itself. And whenever we multiply a negative by a negative, we're going to get a positive. So after you square your numbers, all of your answers should be positive. And if that's not the case, you'll want to go back and double check that. And if you're having any trouble with how you're not sure how your calculator deals with the negatives, at this point, when you're squaring a negative, you can even just omit that negative sign. And so for instance, if I'm trying to square negative 16.5, then I could actually just square 16.5 and that answer is going to be the same because those negative signs will basically cancel each other out there and become positive. And so for negative 16.5 squared, I'm going to get 272.25. I'm going out to 2 decimal places here. 15.5 squared is going to give me 240.25. 4.5 squared is going to give me 20.25. And negative 3.5 squared is going to give me 12.25. And so x minus m squared, next thing we do is we're going to add this up. And so if I add up these squared deviation scores, what I'm going to get is 545. And so then we're going to take that and we want to divide by n minus 1. And so here, let me move this over here. So we have 545 divide by our n is going to be 4 minus 1. 545 divided then by 3. And that's going to give me 181.67. So this is going to be my S squared. That estimated population variance. So I'm going to make a couple of notes to myself here as I'm finishing up. There's a couple of things that we need that we don't really have to calculate, but are going to be part of this process of getting our comparison distribution. So for instance, here in step D, I'm going to note that the mean of my distribution of means is going to be the same as my population mean. And in our dependent t-test, we're going to assume that that is 0. And next I'm going to find the standard deviation of my comparison distribution here. And so to do that, I'm going to get the square root of our estimated population variance, which is what we've got over here, divided by n. And so let me carry this over this way here. So I just sub in my S squared from my S squared here. So the square root of 181.67 divided by n, which we said was 4. And that's going to give me the square root of 45.42. And I get the square root there. That's going to give me 6.74. And last but not least here, let me get a second sheet of paper here. Last part of getting our comparison distribution information is going to be to note our degrees of freedom on what really the shape of our distribution is. And so our distribution, because we have a t-test, this is going to be a t-distribution. And we know that our t-distribution, the shape of that changes slightly depending on our degrees of freedom. And so this is going to be with n-1 degrees of freedom. And we've said in our case, that's 4 minus 1 or 3 degrees of freedom. And that's what our shape is going to be. So step 3 here is going to be to find our cutoff score. In our case, we're going to be using a value of 0.01 here. So let me pull up my t-table here. And so we want to look this up on our t-table. We have 0.01 is going to be our significance value, or significance level. We noted that we're looking at them eating less sugar in this case. And so we know that we're going to have a one-directional t-test, one-tailed test, because we have a directional hypothesis. So I'm going to make a note here that I have a directional hypothesis, which means I have a one-tailed test. And we know that I have 3 degrees of freedom here. And so if I look up on my t-table, I have a one-tailed test, 3 degrees of freedom at the 0.01 significance level. I should find that my cutoff score should be 4.54. And because we're looking for less added sugar, that's going to be a negative. And so we have our cutoff score here. And so now at step 4, what we're going to do is we're going to calculate what our sample t value is. And so we're going to use the formula t equals m minus mu over s subscript m. And so what this is we're going to have our mean of our different scores minus the population mean all over our comparison distribution standard deviation. And our mean and our standard deviation of our comparison distribution, we've already calculated here. So we said that our mean of our difference scores is going to be negative 17.5. I already said that our comparison distribution mean is going to be 0, and we found the standard deviation of our comparison distribution. So I'm just going to plug these numbers right into this formula. So we have negative 17.5 minus 0 over 6.74. So that gives me negative 17.5 over 6.74. And if I calculate that, I'm going to get negative 2.596. And when I round that, that's going to be negative 2.60. And again, typically in AP format, we're going to be rounding out to 2 decimal places. So then I have my sample t-score. So in step 5 here, what I'm going to do is I'm going to make my decision about whether I'm rejecting or failing to reject my null hypothesis. And so typically I like to draw this out. We know that our t-distribution isn't the same shape as a normal distribution, but I can still draw a curve here. I can also just draw a number line instead if I want. Either is fine. And I like to just, again, this doesn't have to be perfect, but I like to just, for the sake of having some kind of visual representation here, write in some numbers here. And so we know that we're going to have, this is going to be past 2, so I want to at least go out a little bit further. Really, I could go out quite a bit further because our cutoff score here is very stringent. And so for our cutoff score, we have negative 4.54. And so I might make this a little bit longer even. Again, it doesn't have to be perfect. The main point here is that we have some representation of how this looks horizontally, even though this is obviously not a very good shape for what this would really look like. And so negative 4.5. So here's going to be my cutoff score. Negative 2.6. I'll be right about here. And so this is my sample score. And so the important part here is that if my sample score is further out into the tails, if it's more extreme than my cutoff score, I'm going to be able to reject my null hypothesis. And here we see that this is just not the case. Our sample score is much less than our cutoff score. It's definitely not more extreme. It's not further out into the tails. It's closer to the mean, actually. And so here I'm going to have to say that I fail to reject the null hypothesis. And so this means that these results would not be statistically significant.